Okay, so previously we talked about a homogeneous equation. So now we're going to talk about non-homogeneous equation. Okay, for the case of so where is our teaching plan? So there is our teaching plan. Okay, so we're going to discuss a linear non-homogeneous equation. So for the case of linear non-homogeneous equation, there are going to be two ways of solving them. First is called as undetermined and the other called as the variation of parameter method for the today. So I'm going to discuss the first method, which is called as the undetermined coefficient method. Okay, let me explain to you first what is the difference between homogeneous and non-homogeneous equation. So the general form of a linear second order homogeneous with constant coefficient. So this is the same equation that we have seen before that I've explained in the previous subtopic. So it's given by a d square y over dx square plus b dy dx plus cy equal the function f of x. So the equation is going to be called as being non-homogeneous if this side of the equation over here it is not equal 0. Yeah, if it's 0, it's homogeneous. Not equal 0, it's going to be non-homogeneous. So I'm going to demonstrate by these two particular example that are going to help you see it clearer. So if I have an equation of y squared plus 2y equals 0, so what happens is that on this side, so my function f of x is equal 0. Automatically, we know that this is going to be a homogeneous second order equation. But for this case, my f of x is not equal 0. So it's going to be defined as being non-homogeneous. It's going to be as easy as that. All you have to do is rearrange your variable. So anything related to the dependent is going to be on the left hand side. Is the right hand side is equal 0, so it's going to be called as a homogeneous equation. If it's not equal 0, it's going to be called as a non-homogeneous equation. So that will be the idea. And as I have mentioned previously, said there are two methods of solving non-homogeneous equation. So first is called as the undetermined coefficient method, or I can call the SUC as a shorter name. And the other method is going to call as variation of parameter, which is called as the VOP. So what is the difference between both of them? I'll explain this in a bit. Okay, now we're going to start with the first method, which is undetermined coefficient method. So if you're using the undetermined coefficient method, so this is how your solution is going to look like. You're going to have two components. So your solution y, so first component is going to be yc and the second component is going to be yp. So you have to find both of them and combine them, then only it will become your solution. So what is yc? So yc is actually something that you have seen before. It is basically the homogeneous solution. So if you refer back to what we have discussed in the previous subtopic, so your yc is going to be either one of these three equations right here. It could be distinct root, equal roots, or complex root. So according to the equation, so that is going to be your yc. So this, why is it called as yc? Because basically it is called as the complementary function. That's the other name of the homogeneous solution. So that is why it has y with a subscript of c underneath. Okay, and then the second component will be the yp. So yp is going to depend on your function f of x. So I'll put over here, so depend on f of x. So yp is known as the particular integral. So that's what the p stands for, particular integral, right? So you have to find yc and yp, put them together. That will be the solution when you're using the undetermined coefficient method. Okay, however, okay, there are one condition that is like super important, that every single time that you write down your yc and after that you write your yp. So right after you have written your yp, so you have to check for this condition. The condition is that your yc and yp, they must be linearly independent. I'm pretty sure that you're not familiar with this term. So before we proceed, first of all, I'm going to explain to you what does it mean by being linearly independent. Or linearly, the opposite will be linearly dependent. Okay, so please be clear with the idea. So the condition is that yc and yp must be linearly independent. Okay, now let's have a look at the definition. So this is what it means by the term being linearly independent or dependent. So according to the definition, so if I have two functions, so the functions are linearly dependent if one is a constant multiple of the other. Okay, this is going to be a very simple example. I have two functions, y1 and y2. So y1 is given by x squared, y2 is given by 2x squared. So what happened is that if I were to multiply this by 2, so multiply by 2, so I will get 2x squared as the function, and it's going to become exactly the same with this. So that is called as being linearly dependent, and that is what it means by being constant multiple, meaning that when I multiply one function by a constant, it becomes exactly the same as the other one. So that is called as being linearly dependent, LD. Okay, so otherwise, if I multiply by any constant and they do not become exactly the same, so they were called as being linearly independent. Okay, so the rule is going to be like this. If when you remove the constant, they become the same, it's going to be called as being linearly dependent, equal LD. But when you remove the constant of the functions and they become not the same, they are not the same, they're different, so it is going to be Li, which is linearly independent. Remember, which one do we want? We want the function to be Li. We want them to be different. So that will be the condition. Okay. So the rule is that remove the constant, it become the same, LD, it become different, it's going to be Li. So I have a bunch of functions right here that I'm going to demonstrate just to give you an idea. So how do we determine between Li and LD? So again, I would like to remind you, if when I remove the constant, it become the same, LD, where if they are not the same, it's going to be Li. And what do we want? Li, linearly independent, they cannot be the same. Alright, so here I have two functions, y1 and y2. So what I'm going to do is remove the constant. Okay, so if I were to remove the constant for y1, so my function is going to be exponential of x. This is also going to be exponential of x when I remove the 5. So I compare them both. So they are equal. So they are linearly dependent. So that is how it's done. All you have to do is remove the constant. So here, remove only constants. Okay, constant could be in terms of numbers, 1, 2, 3, 4, 5. Or it could be in terms of like what we have seen before, A, B, C, D, and so on. Remember, if you use alphabet to represent without no function, for example, if it's A by itself, constant. AX, it's a variable, and so on. Okay, so I'm going to do the same for the second one. So for the second example, I have y1 equal 3 exponential of x. And of course, for this case, when I remove the 3, my function is going to be exponential of x. y2, I have 5 exponential of negative x. When I remove the 5, it becomes exponential of negative x. Are they the same? No. One is given by power of x. One is given by to the power of negative x. 1 and negative 1, they are not the same. It has to be exactly the same. Then only we call it as being the same. Or in other words, sebiji sama, then only we're going to call that as being LD. So therefore, for this case, they are not the same, not equal. So automatically, these two functions, they are linearly independent. So that's how you tell. Okay. So now let's move on to the third one. Similar idea. When I remove 3, I'll get exponential of x. Remove 5, I'll get x exponential of x. Remember, only remove the 5. Why don't I remove the x? Because x is a variable. You only remove constant. And of course, when I compare both of this, they are not the same. Automatically, they are linearly independent. Because one is exponential of x, one is x exponential of x. For the fourth example, so what happened is that I have, instead of like having only one function for each, one term for each of the function, so I have multiple terms. I have 2 of them. So what you have to do is you have to check for each of them. So you have to make sure that none of the term in both functions are the same. For example, if I were to refer to y1, when I remove the 2, this is my function. Remove the 3, I'll end up with exponential of 2x. And on this side, when I remove 2, I'll get exponential of negative x. Remove 5, I'll get exponential of 3x. And then I compare the exponentials. Are any of them are the same? So this is exponential x, 2x, negative x, 3x. Nope, none of them are the same. So they are not the same. Automatically, these two functions, they are linearly independent. So that is how it's done. Okay, and for 5, I have a function, but here I'll make it slightly different, for which I actually have a bracket around. When you come across something that looks like this with a bracket around, before you proceed with doing anything, please expand the bracket first. So here, when I expand the bracket, I'll end up with a exponential x plus bx exponential of x. Then only I'm going to start comparing. Right, so upon comparing, So when I remove the a, remember, as I mentioned to you before, not only numbers are going to be constant, even the alphabet A, B, C, D, and E, or whatever that is, those are also going to be considered as being constants. So when I remove the a, I'll get exponential of x. I remove the b, I'll get x exponential of x. And when I remove c, I'll get exponential of x. And when I compare, I figure out this term and this term, they are exactly the same. So when they are the same, automatically, this is going to be considered as being LD. So none of the term in y1 and y2 must be the same. Like when you have one term that are the same between both of them, automatically they are going to be linearly dependent. Alright, so it will be the same idea for the last one over here. I have y1 a cos x plus b sin x. Again, I will remind you ab. So let me change this. I shouldn't be using the same constant. C and D. So I have a to z to choose from. Okay, A, B, C, and D, they are all constants. Okay, and as I mentioned to you before, when you come across something that has a bracket like this, so please expand them first before you start comparing. So I'll end up with C exponential of x cos of x, and this one is going to be D exponential of x sine of x, and then I'm going to start comparing them. So when I compare, when I remove the a cos of x, remove the b sine of x. So this is actually going to be exponential x cos x, because remember, I only remove the c. And when I remove the d for this case, I'll end up with exponential x sine of x. And then I'm going to start comparing them. So when I compare all of them, they are not the same. This come with exponential, the other one without. They are not exactly the same. So therefore, they are not equal. So these two functions, y1 and y2, they are linearly independent. Okay, so those are like how you're going to determine whether function are Li and Ld. So that is what you're going to do in order to fulfill these conditions right here. So the fact that you have to check, where's my condition? So the fact that you have to check here that the yc and yp, they must be linearly independent. So we don't want the terms to be the same. All of them has to be different. Okay, later I will explain. So what happens if they're the same? What should you do?